Okay, good morning, everyone. Let me see. Yes, I am unmuted now. And everything is running. Very good. The recording is started. Welcome at this next HPE server update session organized by Tech Data. Very good to see all of you here. Thank you for your interest and your time. Yeah, a few weeks ago we had that storage update webinar. Soon we're going to have network updates, SimpliVity, hyper-converged updates. We had a DHI session last week as well. All the recordings are available. But a lot of things are happening in IT, right? And so this is why we organize now. It's quite some time that we organized a server update session. But finally, AMD and Intel, they organized an update in their CPU line. And so this is what we're going to take a look at. So what did I do? I took 3 tech talks. HPE is organizing for you. Feel free to look at them. Tech talks, you can find them on techpro.hpe.com, which is, the portal for sales, pre-sales, and technical people. You can find a lot of information in there. So there are tech talks. It's always 1 hour, 1.5 hours that you can take a look at it. And so I took these 3 presentations and I put it all in one. Okay, so there's a lot of information that will be coming to you. So let's get started. You will get a copy. You will get a link to the recording as well. And if you have questions afterwards, guys, feel free to contact me. There's my email address. And also at the end of the presentation, you will find the phone number and email address of the HPE team as well. So let's get started. First of all, why are there updates on Intel and AMD? Okay, we know the TikTok mechanism. Every few years, we're going from 20 to 17 to 14 to 10 nanometers and so on. So there are redevelopments of the silicons. But of course, why do we do this? Yeah, because there are changing needs to the applications that are running on top of it. Okay, and it's not IT that is transforming; it's also the customers that are transforming. We don't only see that when we're talking about how many cores and how many memory, about the speeds and the seeds and the feeds and so on. But it's also about the consumption of IT. When we're going to take a look at GreenLake, everything as a service, also POINTNEXT, the support team is changing. We're going to take a look at that in a moment as well. So everything needs to follow, okay? So I want to highlight already, before we dive into the technical details of what is announced by Intel and AMD, that also on the support side, you will see this in the presentation, that from now on, the support on the products is also changing from a product towards a solution. So you should know, and by the way, we have another presentation about this with more details. Know that the foundation care and proactive care, which we are selling already for so many years, know that this is being replaced now by tech care. Okay, so from now on, all the new servers that you're going to see with the new Intel, with the new AMD that we're going to talk about today, you will see that there will be now tech care. Okay, so foundation and proactive care is gone. That was up to Gen 10. Now we're going to talk about Gen 10 plus servers. Well, you will see that also the support experience will change. So it's called tech care. You know, on top of that, there is still data center care. There we're really talking about an environment that is being supported by HPE, which is a little bit out of scope for this. But you should know that. And if you want more details, know that we have a presentation about this with more details. But it's also about the support, that you will get much faster access to the experts to get that better support experience as well. Further on, we will see that the presentation is split up. We're going to take a look at, first of all, the workloads. We're not going to talk about an application or whatever, or so many cores and so many memory. We're going to talk about workloads. In all our discussions, we're going to take a look at the management. Security is always there. And we're going to talk about scalability, the architecture underneath it as well. So workloads, this is why you will see that there are so many changes on CPU and memory level. It's true. Until several years ago, we were talking about an SQL server and the file server, and then we were virtualizing everything. But today we're doing much more than that. With the pandemic, everyone is working at home. I see a huge request on VDI. I see more and more data management also due to COVID. We need more intelligence. We need more compute power to do the calculations to find that vaccine, to help us to get out of our house again. We have the data analytics. We have containers, the new style of development. We have DevOps with containers, with the Dockers and the Kubernetes of this world. So we see much more workloads coming. Take a look at that annual growth rate, which is huge. Right? We need to do more. And this is why AMD and Intel keep on evolving with their CPUs and other products as well that they put in the market. And so this is where we're going to take a deeper dive into both of them. We're going to take a look at the AMD MILAN processor. So the MILAN processor is a third generation now. We had Naples, and then we had a Rome CPU, which you can find in the Gen 10 servers. Well, now we have Gen 10 Plus servers, though it's not Gen 11 yet. That will be the next one. So today we call it Gen 10 Plus. You will see later on why. And also with Intel, we have Ice Lake. In Gen 10, we had Sky Lake and Cascade Lake CPUs. Well, now we have also that third generation in the scalable processor from Intel, which we call Ice Lake. And so these are the first models. So you see a glimpse already of the models, and you know probably, I assume that you know that the ProLiant servers ending with a 5. These are AMD-based machines, and the servers ending with a 0 are based on Intel. So that's a good refresh. What do we see here? Look at that. We know that we had a DL325 and a 385. Well, no. And I have more details and pictures about these models in the presentation. We have a 345. We have a 365 as well. In the Intel series, there is the most sold, very popular DL360, DL380. There's also a Synergy update for the bladed environments, but now we also have a DL110 server available as well from Gen 10 Plus on. And so I have all the details in this presentation. Also, when we're going to talk about management, this is not from now, today on, and everything has changed. No, you will see in the upcoming months, in 2 weeks from now, there is HPE Discover, the yearly big worldwide event with all the announcements. Well, I can tell you there will be a lot of announcements on all this. So at the end of this month, we have an HPE Discover update session. Well, come take a look, and you will see that there will be a lot of announcements on the management side, that we're not talking about products or feature-centric, like we have an ILO, we have the amplifier, we have OneView, we have InfoSight. You will see now as well that everything will be changing. I'll give you a glimpse already about it. What happened now with storage? Take a look at our presentation of 2 weeks ago about the new style of storage. DSCC, Data Services Cloud Console. We have Alletra 6000, 9000. Everything is going to the cloud, just like Aruba Central is doing. Well, you will see what will be announced really soon. It will be the same vision, the same idea. We're not going to talk about products anymore. And so the Gen 10 Plus servers today are ready for that. Together with the workloads, we don't care. We have those features, we have VMs, we have containers, we have bare metal applications. We don't care anymore about the applications and the host operating system that is running underneath it. All those other services will be on a control plane, which is separated from the data plane, which is something that we see already with virtualization, with containers. In storage, well, now you will see in compute as well that we're going to separate the data plane and the control plane as well. But this is upcoming. It's it's the start. The foundation is there, the software is there, the capabilities are there. It's just, yeah, the whole framework will be announced in a few weeks from now. But believe me, 2021 will be it was already a challenging year, and it will be even more a challenging year for us. So stay tuned. Okay, let's take a look at the details, right? So first of all, let's take a look at AMD, because they were first with their announcement. It was somewhere the end of March timeframe. They announced their next generation of CPU. So like I said, we had Naples and Rome. So we had a DL325 Gen 10 server. It's still there. Very important message here, I will say in a minute, but DL325 Gen 10 was there with the Naples CPU. Then we had the Gen 10 Plus server with the Rome CPU. And now we have the Gen 10 Plus V2. My opinion, I agree. It's not ideal, this naming convention, but it is like that. I didn't invented it. But that V2 means that we have that third generation of the Milan CPU, so which is announced and available today. Okay. So the same for the DL385, so the big brother, the 2U CPU, because there we had the Gen 10, the Gen 10 Plus, and the Gen 10 Plus V2. Now, on top of that, you see that there are a few new models. So we have the DL345 and the DL365. So these are two new models. For some kind of reason, we don't call them the Gen 10 Plus V2s because there wasn't a version 1 of that one. But we should know, and you should know, now you know, that since it's the first generation of that model, so there's no V2, but the Gen 10 Plus on the 345 and 365 are based on that new third generation, the Milan CPUs. You can find this all in the quick specs. Now, there's one important thing that you should understand, and I will keep on saying this later on through the presentation because it's the same for Intel as well. Gen 10 Plus is not replacing Gen 10. Now you will see that indeed the Naples CPU will end somewhere because it's an older architecture already. So AMD will stick with Rome and Milan, but you see that the Rome CPU keep on going and that the Milan comes on top of it because Milan gives you even more performance. You will see later on with Intel as well that Gen 10 Plus is not replacing Gen 10 as such. So Gen 10 is staying and Gen 10 Plus is indeed a performance, a high performance model on top of Gen 10, but Gen 10 is not end of life yet. Let that be clear. That will happen only with Gen 11, but Gen 11, that will be next year. It will not be definitely this year. Okay, so that's an important message already. So also for AMD, the Rome-based CPUs, they will keep on going in parallel with the next generation Milan CPU. So here's a picture of this because like I said, you will get a copy of the presentation. There are so many slides in there that I will show you, but all the rest is there for your reference. Okay, so there you go. We have Naples shipping already from 2017, early 2018. Then there was Zen 2, the next generation Rome. And so now we are here in that third generation or Zen 3 level, which is now Milan. Know that for next year, AMD is planning a fourth generation Zen 4 already. It's in design now. And they have something with Italian cities. So the fourth generation will be Genoa. Code named inside the company. What are the differences? I'm not going to dive too much into details. This is for the techies among us, but this is just to show you the evolution of what is changing. So AMD was already at 8-channel memory. Intel was at 6. You will see what's happening now with their next generation as well. But here we have 8 channels. The speed is going up. And why AMD today is so popular is because they were already at PCIe generation 4. Okay, so they have more bandwidth already since some time, since 2 years. They have already PCIe generation 4 so for those applications that require a lot of bandwidth at that moment, AMD is definitely a good investment. Now, what's changing between Rome and Milan? Because you say, hey, this is all the same, right? Well, you will see that the power is a little bit going up, but that means as well that you will get more cores, more gigahertz available as well. So it's definitely a step up in the performance. I have more comparisons coming. Here's the lineup today. So I told you we have the 325, 385, 1 and 2U model, but now we have a DL345 and a DL365 as well. Now, you see them for their specific workloads, because here you will see, hey, that DL345, it didn't exist before, and now it looks like a DL385 because it's a 2U server. That's right, a 2U server means that you have a lot of storage capabilities. There you go, large storage capacity, but it's a 1P server. So like the 3L325 and the 345 is the same like the 365 and the 385. It's a 1U and a 2U server, but the 360 and the 385 are 2 physical processors. The 325 and the 345 are 1P processors. Why is that? Well, for instance, for specific applications, also to optimize maybe licensing costs, because there are some applications out there, yes, that are, for instance, databases. Do you recognize that one big database company that is also popular for their licensing based on those sockets? Well, now AMD can deliver you 64 cores with 1 physical socket, so to optimize your licensing. Okay, and you have large capacity just like the DL385. So you see here as well which type of workload that is optimized for those servers. Okay, because yes, I get those questions, and the people from the HPE team, when pick which server? Well, there you go. This is already to give you a good idea where we're going to use which model. I'm not going to dive into this. I just put it in here. It comes from the Tech Talk presentation. This is all quick spec stuff, but this is to give you an idea. AMD with the Milan, we can go up to 64 cores. Yeah, real cores in there. It's the 7763 model. The 3 at the end means that it's the 3rd generation of CPU, that it's a Milan CPU. But now you see as well that they're all at those higher power levels, yeah, because they have that higher, so the TDP, the thermal design platform, so they consume more power. Also, cooling is of course very important, but this is why the gigahertz are also rather high. You see here numbers up to 3.7 gigahertz, which is really huge for this kind of CPUs. Note that there are other models coming, so everything is not available yet. So in the upcoming months, you see, this is just to give you an idea. This is the roadmap, but it might be a little bit earlier. It might be a little bit later, because you know there are some constraints as well on resources in IT, if you didn't know yet. But this is just to give you an idea that there are more CPUs on their way in those specific models, to give you a more complete selection of choice. Now, here is an example of the CPUs. Not all the CPUs are qualified in that 345 and that 365 at launch either. It might change. This is why I always say, guys, please take a look, because this tech talk is also from 5 weeks or something like that ago. So maybe it changed already. Please take a look at the quick specs. Also, my colleagues, Wim, Steven, and Christophe, they will also validate this together with you. Now, these are the typical slides that we see, that we know from the products. What's the most important here? So 325, lower cost, so it's cost optimized. It has a shorter chassis depth, as well. There's a little bit of storage capabilities in there. We're going to talk about storage soon as well. So you see there that we have 4 LFF drives, 8+2 SFF drives. And now because we have PCIe generation 4, yes, we're moving towards NVMe. If you followed our presentation about storage update with Alletra 6000 and 9000, what's the biggest difference? Yeah, cloud-based management, but also NVMe, lower latency, even higher performance for your application. So now you will see as well that thanks to PCIe generation 4, we have more bandwidth. Now we can go up to that next generation SSD, lower latency NVMe storage. So you will see as well in here NVMe drives. So I told you PCIe Gen 4, typical workloads, put VDI on there. Yeah, high performance, low latency VDI is a fantastic platform for that. Comparisons. I'm not going to tell you all the differences between everything, but you will see the difference between the Rome CPU and then the Milan CPU, because remember we have Gen 10 Plus and we have Gen 10 Plus V2. And so now you see the difference between when do I pick the Gen 10 Plus server, when do I pick the Gen 10 Plus V2 server. What do we see? The server is physically smaller, which might be a good thing depending on the rack that you have in your server room. You will see that you have more capabilities towards NVMe. Yeah. Also here, an important thing, and this is why I have a dedicated section on storage as well. At the end of this presentation, we're going to talk about storage. Why is that? Because yeah, there are changes that you need to be aware of. Until now, you will see that HPE, all ProLiant servers, we were using a carrier called a smart carrier. So that carrier was the same in all the ProLiant servers and so on, but it was a specific carrier optimized, designed by HPE for HPE servers. Now, we see also a trend in the market where everyone is going to a standard open platform layout. So you will see now from Gen 2, Gen 10 Plus servers on, you will see that we will be using basic carriers. So watch out. Yes, the carriers are changing from the SSD drives, from the SAS drives, and definitely then from the NVMe drives. This is just to open it up to the market so that the carrier as such is exactly the same for everyone, so that we don't have that lock-in anymore. You'll see later on, I have pictures about that, how it looks like, what's the idea behind it. So you should be aware of that. Also, the second important thing on storage is about the controllers. Yes, there are, we have also a change on the storage controllers. I have the complete lineup in the presentation as well for you, but now you will see, since we have SAS and SSD and SATA, yeah, but now we have NVMe as well. Well, you will see now that there is a new thing called a tri-mode controller, yeah, and the tri-mode controller, yeah, supports all the 3 modes, of course, for hardware rate, also on NVMe drives. Know that it's available today with those tri-mode controllers. Again, more details later on in the third section of this presentation. But that's the most important thing, as you can see. So like I said, Gen 10 Plus is not dead. It will keep on going. Also for those customers who still have those smart carriers, for instance, it's a really good service. Of course, if you want to invest in time on the long run, of course, at that moment, you should take a look at Gen 10 Plus V2. So this is how it looks like. We have by default 8 SFF drives. That bay here can be replaced with an optional media bay. So now there's no media in there, but you can add an additional 2 SFF drives in SAS, SATA, or NVMe. You can put NVMe U2 drives in there, or maybe even, does it still exist? Yes, a SATA DVD-ROM, an optical drive. Know that it's technically possible, but that's a long time ago. I have seen that one. But never say never. Yes, it is available. So there you go. We have those different front drive options. I have more pictures, more details in the third section of this presentation. Picture at the inside, DL325, it's a 1P server, so a one socket server. We can put 8 DIMMs in there. Hold on, 8 plus 8, it should be, yes, fully populated. We can go up to 16 DIMMs. There are only 8 now on the picture, but installed, but we can go up to 16 DIMMs per CPU. Of course, a lot of cooling, redundant cooling. In the front, we have the storage. At the back, we have the power supplies, and we have the PCI riser cages. Yes, you can have a second and even a third PCI riser cage. I have more pictures about that coming as well. Picture at the back. So one important thing with Gen 10 Plus is now that we have those NC motherboards. So we don't have networking connectivity anymore on board. So we only have that ILO connection in here. So now it's up to you. You have to put network cards in there, 1 gigabit, 10 gigabit, or 25 gigabit. So don't forget that one, of course. And so we have multiple PCI slots, full height and half height PCI slots that are available. So I told you about the architecture. We have in total 128 PCI lanes, and now it's up to you to decide how you're going to use those PCI lanes, because we have multiple architectures available. You see this in the quick specs. The slides are coming with more details, but so now you can choose yourself depending if you want to put SATA or SAS or NVMe drives in there, because of course for those NVMe drives, they are directly connected on the PCIe bus. So it's up to you to choose that configuration. Be aware of that. So you will see in the part numbers that you have models. So you can see here, so we have the SFF basic carrier, or we have the LFF low profile carrier, okay? And then with the small form factor BC carrier, you have a model where you only have SAS and SATA, or you have a model where we have that tri-mode connectivity with NVMe only, or even with SAS, SATA, and NVMe. So yes, I admit it's I don't say that it's complicated, but it gives you more flexibility, and more flexibility gives you more choice. But sometimes I admit that it's, yeah, which one do I need to take? Yeah, so yeah, it's like that. We have to think about that. My colleagues, they will ask you as well, are you sure that you're picking the right one? Because this is all CTO configure to order configurations. The same for the DL345. Remember, DL345 is the same one, but with a 2U chassis. So we have more capabilities for more storage, right? But it's there you go. It's a shared board of the DL325. So it's the same motherboard, but it's a chassis of a DL385. So with more storage expansions in there. So now you will see as well, we have that new third generation AMD EPYC MILAN CPUs. We can go up to 3200 megahertz, 4 terabyte RAM in there. We have the possibility to mix SATA, SAS, and NVMe drives. And now also, this is not possible in the 325, but now in the 345 and 385, we can have those two SFF basic carriers as well at the back. Besides that, it all is the same with the previous server picture. So we have those 3 drive bays with 8 drives. So what you see here is indeed the 8 SFF SAS SATA drives, and then we have other drive bays, for instance, also for NVMe. So here you see those front drive options, more options of choice. We have those SFF NVMe by 1 or by 4 generation 4. Again, how many bandwidth do you want to your NVMe? So again, this is the same picture. So I told you it's the same motherboard. So it's a 1P, one physical socket with up to 16 DIMMs. We have bigger fans here because we have 2U with the drive cages in the front. Here we have a picture with 2 PCIe riser cages already. And then we have our power supplies at the top. It's a similar design. Of course, it's just a little bit higher. And here you see as well, no default network connectivity. Here you see in slot 15, that's that OCP slot. And so we called it a FlexLOM slot in the past. Well, now it's an OCP slot because this is also now based on open standards. And so we have now that 10 gigabit OCP card in here as an example. And as you can see, we have, of course, more PCIe slots available to install cards in there. Again, here, this is exactly the same like with the DL325. So we have multiple possibilities. And so you have to choose again between LFF, SFF, and then what you're going to do, you're going to do SAS SATA only, or you're going to do that other mode. I'm going to talk about that later. What's the difference between that U2 and that U3 kit and so on. So that's indeed that universal cage that we're going to be using later on in the presentation. There is a specific tech talk on storage only that I have in the last section of this presentation. DL365, this is the smaller brother of the 385, of course, okay? So it has a shared board of the DL385, but it has the chassis of the DL360. So it is a 1U server, but with 2 physical sockets. Okay, so here we can install 2 CPUs in there. So we will have more bandwidth, more PCIe lanes available. Okay, so there you go. We can have 2 AMD MILAN. We have 32 DIMMs, smart memory, 8 channels per CPU. And then we have similar, a mix of HDD, SSD, and also NVMe drives. So here's a picture. Again, 8 plus 2, a maximum of 10 we can have here. Picture at the inside. So there you go. Now you see clearly the 2 CPUs, 32 DIMMs in there. This looks like a DL360 as well. More cooling, double fans for redundancy, drive cage in the front, PCI, and power at the back. And so here again, here's a picture of, again, no standard networking. So there is that in slot 9. Now you see that OCP slot, which is filled in with a network card. Okay, similar. Again, for CPUs now, you should know that we have a certain, every CPU has a certain number of PCIe lanes. Remember, now since we have 2 CPUs, of course, we have more PCIe lanes, which means that we can have now that tertiary riser with a by 16 slot. And of course, on the first CPU, you lose some lanes because we have, for instance, onboard SATA as well. We have the ILO, we have some dedicated specific functionality on the first CPU. So, but now you will see that you have much more PCIe lanes compared to the previous one in Gen 10. So the speed is double. So speed is definitely going up. And this is why I keep on repeating, I keep on saying Gen 10 Plus is really a performance model of the Gen 10 Plus or the Gen 10 servers, because we have much more bandwidth availability. Again, I keep on repeating it. Plenty of choice, but it's up to you to decide what do you want. Do you want with NVMe or without NVMe? Because it's at that moment that you're going to see that we're going to have to make a choice in that different backplane. And I have pictures about those backplanes coming in the presentation as well. Okay. Then the fourth model, it's a DL385. DL385, so it's a 2U server with 2 sockets. So it's like the DL365, but it's an existing chassis that we had already in the past. And here you can see as well a lot of storage, the most of the bandwidth. Of course, we can put the most of NVMe drives in there, up to 24 NVMe drives. Why is that? Because for 24 NVMe drives, we need a lot of PCIe lanes. But since we have 2 CPUs, we have effectively a lot of PCIe lanes. A comparison between the first, the second, and then, yeah, the third generation. So the MILAN CPUs now. So we have more higher speeds of RAM. We have that tri-mode controller that we're going to talk about later as well. So we have more capacity that we can install in there. We have plenty of OCP, LAN on motherboard slots, cards, and then stand-up PCIe cards that you can put in there as well. So here's again a picture with our multiple front drive options. This looks all similar to the other models that we have seen before, like the 345, but the difference is indeed back again, it's the same model or the same motherboard as the 365. So we have 2 CPUs, 32 DIMMs in there. We have OCP cards here at the bottom, and then we have stand-up PCIe cards at the top. And here, since it's a 2U and we have enough bandwidth, you will see that we have a first, a second, but now we have that tertiary riser cage available as well for the ultimate bandwidth. And it's because of this that now you will see that indeed we have a huge amount of possible options and part numbers about, yeah, what do you need? NVMe only for that really big database, SAP HANA, whatever that you're running on it in memory. You want to run AI, you want to run ML, then you go for NVMe only. If you say, yeah, I want to run virtualization on it because virtualization runs fine on this server as well, and I want a mix of SAS and SATA and maybe NVMe for a specific application, well, know that we have. It's all about that carrier at the back, that drive cage that will change. I have pictures coming as well. So here is the same picture as the 365. So we have a lot of PCIe lanes. Some of them are used. The other ones are available, of course, for you. And so this is already to give you an idea. I have pictures coming, but this is to give you an idea about that backplane type, because now we have several backplanes. We have a by one NVMe SAS model with the basic carriers now, so the new drive carriers. So now you can see the bandwidth. At one moment in time, you can go work with a splitter, but that by 4 without a splitter, at that moment, we have straight cabling, full bandwidth to every NVMe drive. Of course, we need the most bandwidth on PCIe, but then you see the difference. Because I see this question coming. Hey, Bart, I see that by 1 and that by 4 backplane type. Which one do I need to pick? Guys, by 1, which one do you prefer? Do you prefer a highway with 1 lane or with 4 lanes? Of course, you prefer 4 lanes. Well, there you go. You will get more bandwidth if you get that by 4 backplane. Of course, at the other side, of course, a highway with 4 lanes costs more than a highway with just 1 lane. Yeah, so that's up to you to decide. So you have that choice. We will help you to make, if you cannot make the choice yourself, we will help you with this. But take a look. We have to take a look at a lot of things, because you will see, I will give you the details about all those new rate controllers as well. So you will see here that we have that try mode and then which base that you're going to use. But most important thing to remember here is between that by 1 and that by 4 is how many bandwidth that we can get through that backplane. Now, honestly, I don't know that many applications that needs 7.9 gigabyte per second. Nevertheless, know that is available. Okay. So this is to give you an idea about the technology from the past. So what do we see here? At one moment in time, yes, we have models. The DL385 supports up to 32 NVMe, but you should know that when using that by for NVMe, by adding more drives on it, well, at that moment, you will see the impact on the performance and how many slots that you have. While when we are working, then because here we have a point-to-point dedicated connection to my NVMe drives, watch out. That moment you have the most bandwidth, but we don't have a RAID controller. So it's the application that needs to do the data protection. Be aware of that. Now with that RAID controller that we have, for instance, that new, the big brother now, the big guy, the 932i, well, at that moment, we're using that by one NVMe, but now you will see that we can go up to these 36 NVMEs. And even we can using those OCP slots, and we have even more slots left for later expansion as well. So it's all about choosing between what do I need? I want more storage or I need more bandwidth and low latency. Okay, I also put this slide in there because I always get once a question about GPU support. Yes, there is, and GPUs is not a problem. So you will see that there are plenty of NVIDIA cards and other cards. Also from AMD has also those cards. Xilinx has cards. So this is all quick spec stuff. Go take a look in the quick specs in product bulletin, and you will find the cards that are supported definitely for those VDI or AI machine learning workloads, video transcoding. These are typical workloads where you're gonna use this, right? So when we're gonna take a look at what is supported on the operating system side, well, most of the operating systems are supported. I'm thinking about the Windowses, the Citrixes, the Ubuntus, the Linuxes, and of course, VMware is supported. Which is not supported, watch out, this is at launch, it might change. However, what do I see here? Older versions. I don't see a reason why we should support Windows 2012 because it's also not supported by Microsoft anymore. Oh, is Internet Explorer gone? Too bad. Okay, yeah, it is still even supported, although that Internet Explorer is not supported by Microsoft anymore. So most of these applications, yeah, it's still there, but keep on going for the last one. Now, one of the reasons I always get a question, hey Bart, why do I have to pick AMD? Why not Intel, right? Well, why is that? Because AMD is fast. It's bloody fast. It's really a Ferrari. They have a lot of world records. By the way, all those world records are made on HPE ProLiant servers. So go take a look at those benchmarks. It is insane. Okay. Multiple benchmarks for all those types of workloads, let it be SQL, let it be Oracle, let it be virtualization. So there are a lot of benchmarks already available on the MILAN CPUs available today. Yeah, we're quite proud of that, that also HPE ProLiant servers, we are leading, we have the most machines with AMD with those world records. One more reason why you should take a look at AMD in a ProLiant server. Okay, good. I think we're almost through AMD. Yes. So this is AMD, guys. I know it's a lot of information. You will get a copy of the presentation. You will get all the pictures, all the slides, all the stuff is in there. Okay. Now, what's up with Intel? Because of course we have Intel, also good CPU, good performance as well. And so what do we see with the next generation? So also here, now we call it Ice Lake. So we had Skylake and Cascade Lake. So now the third generation of the scalable processor of Intel is now called Ice Lake. Okay, also here it's Gen 10 Plus. It's not Gen 11 yet. That will be the next one. And finally, a very important, because there Intel was a little bit lagging. So AMD had 2 years of experience with PCIe 4. Well, now finally now with Ice Lake CPUs in Gen 10 Plus, starting with the DL360 and the DL380, and in Synergy as well. Now we have also PCIe Generation 4. So now we have more bandwidth to get those higher performance as well. Now, again, for me, this is a very important one as well. Gen 10 Plus is not gone. It's not end of life, something like that. It's not that Gen 10 Plus now is replacing Gen 10 servers. No, Gen 10 servers. Here it's clearly stated Gen 10 Plus is not a replacement. It's an extension of Generation 10 servers. Yeah, Generation 11. It depends on Intel, guys. Probably it will be 2022. So next year, there will be Gen 11 probably. But it depends on the next generation of CPUs, of course. But let it be clear, at Intel, we keep on having Gen 10 servers. So they're not old. They're really good for your typical workloads. And Gen Plus is an extension on it. So it's really... I got already some questions that, hey, take a look at the pricing. It's more expensive. Yes, because it's higher performance. Okay, you will see in a minute. We have higher speeds, more cores, and we can go up to 40 cores. Now we're not yet at 64 like AMD, but Intel, we were at 32. Now we can go up to 40 cores. More speeds, definitely more bandwidth with PCIe Gen 4. If your customer says, yeah, I just need 10 gigabit network cards and a RAID controller, and that's it for my virtualization, keep on using the Gen 10 servers. Okay, they're really rock solid servers. Gen 10 Plus is there for higher performance. So these are the models that were announced. I didn't put the Synergy on here because Synergy is quite specific, but know that the Synergy 480 bladed server in a chassis model is also there, available now with Gen 10 Plus as well. But these are the main models. So the DL360, it's a 1U server, but with 2 processors. And then the DL380, it's a 2U server, most sold server in the world already for more than 20 years. 2U chassis with 2 processors. Well, now there is a third model that has been announced, which is a DL110. Now watch out before you're gonna start ordering that DL110. Know that DL110, I have more pictures about it, but the DL110 is specifically positioned towards telco environments. So it's the first server for HPE that supports the Open RAN, the radio access network. It's an open platform, for instance, for the deployment of 5G networks. Okay, because with 5G, we need more and more in the edge calculations. Well, that DL110 is an ideal telco server for that. As you can see, it's really a short server. It's just 17-inch deep as well, specifically for those telco racks. I have more pictures about it. Very important slide, guys. Gen 10 keeps on going. So it's not end of life. It's the Gen 10 Plus that is an addition to the portfolio. We start with DL360, DL380, DL110. And as you can see, there's also a DL20 on its way as well. Okay, but that's for after the summer time frame normally. But the most popular models being the 360 and the 380 is there. And then, like I said, the 110 for specific telco environments. Here you can see, there you go. Again, I don't dive too much into the details. This is just for the techies amongst us. This is quick spec stuff. You can find this in the quick specs in product bulletin, for instance. But the most important thing now is that remember with AMD, the 3 is at the end of their code name to show that it's a MILAN CPU. Well, with Intel, it's the second digit, which shows that it's now an Ice Lake CPU. Okay, so 864 and 3 points that it's a platinum or a gold or a silver or a bronze CPU. That's the naming convention of Intel. Now the second digit being a 3 showed that it's an Ice Lake CPU. And so now you can see here that the top model now, the 8380, has 40 cores running at 2.3 gigahertz. Okay, maximum of RAM, 6 terabytes. So we're coming from 3 terabytes. For those customers who are not happy, who don't have enough with 3 terabytes, well, at that moment, we're going to talk about the Gen 10 Plus servers, because at that moment with Ice Lake, we can go up to 6 terabytes of RAM with 2 CPUs in there. Okay, There are more CPUs coming. Yeah, they're launching a little bit later. Like I said, there are the 5 and the 4 series, so the lower end gold and the silver models. Yeah, they are on their way, but you know that there are constraints on material, and so they are positioning this as the high performance model, because in this lower range of CPUs, guys, believe me, a Gen 10 server is also performant. It's specifically, I don't think that that company that is looking for a really cheap CPU here, but they're gonna buy the server because they need PCIe Gen 4, right? Or they need not that many cores, but they need 6 terabyte of RAM. That would be really specific. Call me, I'll make you a good price, but this is not a traditional typical workload at that moment. Keep on going with Gen 10, of course. I get a question in the Q&A. So yes, remember that there is Q&A open, of course. What about Ice Lake on SimpliVity? Well, Ice Lake on SimpliVity will be there one day, but not in the near future. Because you will see again as well. Why do we want PCIe Gen 4? Well, also here we're going to talk about NVMe to run those applications for the lowest latency. This is why there is Alletra 6000 and 9000 as well. Well, you will see that it will come to SimpliVity, but it's not the highest priority, because a typical SimpliVity customer today is not looking at the lowest latency below 1 millisecond. Okay, when we're going to talk about tens or hundreds of microseconds, this is not a typical workload, yeah, that is going to run on a SimpliVity environment. Okay, but yes, one day it will be there, but like I said, it will be only the higher model of performance model, so it will be also not make it cheaper, of course. But of course, yes, one day it will be there. Do you have to wait for it? Will I go to a customer and say, yeah, you know, you want to go for SimpliVity, but wait 3 or 4 months and then you get Ice Lake? No, definitely not. These are two different things, okay? Yes, you can always keep on waiting. Then you can wait for Gen 11 as well, of course. And yes, one day there will be Generation 12 as well. You keep on waiting. Now, this is specific workloads. Those customers who need 6 terabyte of RAM, for instance, because remember with Gen 10, with Cascade Lake and Skylake, we have now up to 12 DIMMs. Remember, 2 times 6 channels. We have 2 DPC, 2 DIMMs per channel, and we have 6 channels. Well, now we have 8 channels. And so now we have 16 DIMM slots instead of 12, because there you go, with Gen 10, we can go up to 12. Well, now we have 16. Well, if you have a customer that wants those 16 DIMMs in there, full bandwidth PCIe Gen 4, this is where you're going to take a look at Gen 10 Plus. Also on the operating side support, all the operating systems that you might expect, yes, they are there. The Windowses, the VMwares, the Linuxes, most of them are supported on this platform. Hey, pictures! Everybody loves pictures. DL360 Gen 10. Okay, sorry, Gen 10 Plus. Okay, freedom to choose Gen 10 Plus, performance-oriented Gen 10. It's also performance, but there's also a focus on the budget. Very important, running in parallel throughout the life cycle until the launch of Gen 11, but it won't be this year. Okay, so 360, 2 physical sockets. You see a lot of DIMMs in there. So in total now as well, just like with AMD, we have 32 DIMMs in there. You recognize this, right? This is a typical DL360 from the previous generations. A lot of redundant cooling, storage in the front, PCIe riser cages at the back with my power supplies. Also here, we have that choice. You have to make a choice between TAA compliancy, that's for in the US. So we will have here those models with an LFF or an SFF chassis. And as you can see, NC means that there is also no default network connectivity. And now I was talking about those backplanes. Yes, so you have to choose between the backplane. Which one do you want? So we have an LFF backplane or an SFF backplane. And when we go for that SFF backplane, which is, by the way, is the most selected one, we have a choice of optional backplanes, which I have pictures of now in the presentation. As you can see here, there is already that backplane type A, B, C, D, E. We have multiple models, and it's up to you again. What do you want? You want a traditional media bay? Well, at that moment, it's just SAS and SATA. Okay. If you want NVMe, no problem. We have a buy one NVMe, which is that converged NVMe, SAS, or SATA. At that moment, we need, of course, a controller that supports this. We're going to talk in a minute about that, about the SR and the MR controllers. Of course, if you want more and you want that connection with the CPU directly as well, at that moment, we go to that by 4 NVMe connection. Remember from the previous slide, what was the difference between the by 1 and the by 4? It was all about the bandwidth and the direct connectivity. And then otherwise, there is as well a backplane NVMe only. Okay, and at that moment you have that direct attached with the CPU as well with the specific cabling. It's here where you can see that tri-mode mentioning. What is that tri-mode meaning? Well, there you go. Again, this is for the techies, but nevertheless, the information is there. Google is your friend, more information about it. Well, the legacy backplane, so the connector is the same. Okay, so it's not that it's a new type of connector, only the connections have different IO, different traffic on it. Yeah, so with the legacy backplane until now in Gen 10, you can run SAS and PCIe in there, because technically all those pins, there are PCIe lanes and a few pins were SAS lanes. And then we have power and sideband connectivity as well. Well, now with that new backplane, that so-called converged backplane, now you can see that there is no PCIe there anymore. It's just lanes. It's just bandwidth. And now it's the drive and the controller at the other side that will define the language, the communication on there. So this is why we call it tri-mode. On these connections, it's just bandwidth. It's just PCIe lanes. You put a car, you put a bike, you put a truck, you put a train, you put a plane on there. I don't know what, but it's just lanes. And that's that new tri-mode backplane. Okay, and so now you can put SAS, SATA, NVMe drives on there. Of course, you have to pick the right drives, because this is, of course, now based on those new basic carrier drives as well. So plenty of options. So like I said, we have those CPUs, we have DIMMs, we have PCIe lanes, we have that driver cage, and now depending of that drive cage, you can put a RAID controller in there, and then you can connect, for instance, with SAS or SATA cables, or then with that NVMe riser, and then there is a specific cabling for that NVMe riser as well. And so now you see all those different backplanes that you can install in here. We have that tri-mode U3 basic carrier backplane kit. So that's up to you in OCA. By the way, in OCA, when you go in there, you see all these components. If it's not clear, hey, we have our experts in the HPE team as well for you that want to take a look at you of what are all the options. But like I said, so we have that tri-mode backplane, we have an NVMe backplane, and so we have that U2 or that U3, the naming convention is explained later as well. But so we have those, full flexibility in those backplanes. There's another backplane where we're gonna install a RAID controller. Also here, I have more information about the current SR RAID controllers. We have now new MR RAID controllers as well. And so from those RAID controllers, we can connect with those by 8 connectors. We can connect to this backplane as well. So we have that by 1 tri-mode connectivity. So we can install SAS and SATA drives in there. We have more options here. We have that one big SR932. So we have 4 by 8 connectors, the 32 points that we have 4 times 8 lanes. So we have more bandwidth to connect to those drives. And then we can have that by 4 tri-mode kit, for instance, as well. So these are all scenarios which are explained again in the tech talk about the storage options that I will talk in a minute as well about. So there are riser options, plenty of riser options. Again, just pick the one that you need. Then we have the DL380, which is the same, but it's the big brother. By the way, I found a picture about the model with the large form factor drives. So now it's LP called. But these are the new carriers with the large form factor drive. So it's still available as well. Again, I keep on repeating, Gen 10 Plus performance-oriented Gen 10 will stay there. And here you see the difference between the two models. So it's about cores, it's about PCIe 4, more lanes, yes, more DIMMs, 8 channels instead of 6 channels. So we had 24, now we have 32 DIMMs, so we can go up to 6 terabyte of RAM. And so you will see as well that now we have that tri-mode options, so that we have one backplane where you can install an NVMe and SAS and SATA. And we're going to talk about those RAID controllers as well. There's now a new thing that Intel VROC that I will explain as well. Very important thing to know. Smart carriers and smart drives in Gen 10. Now we're going to talk about basic carriers. So one important thing, I know who is in this call. So I know that in 6 months from now, you're going to call me and you're going to say, hey, Bart, isn't it possible to take a drive of a Gen 10 server and put it in Gen 10 Plus? Well, then I will tell you, guys, you were in my presentation. I told you. We are moving, we're following the standards, we're following the market, going to those basic carriers. Okay, I get a question about Bart, no standard NICs on the DL360 Gen 10 Plus. Well, no, just like with AMD, these are NC motherboards. Yeah, there's a picture at the back here. In a minute, there you go. Answering live, there you go. No embedded LOM anymore. We have that OCP standard, which are like LOM cards, but now that card, it's open. It's not HPE proprietary. Now you can go to, let's say, Broadcom or Mellanox or which one others do you have? And you can buy those cards and put them in there. Okay. So it's that NC, you have network choice. I call it no connectivity, but officially it's called network choice. So it's up to you to install, to add that OCP card in there. And by the way, my colleagues from the HPE team, when they are delivering those bills of materials, they will ask you, guys, you need a network card. Automatically, they will put a network card in there because a server without connectivity isn't. By the way, what's the reason? Why is HP not putting those network cards in there anymore? Well, because of the maker, the vendor of that network card. If I remember well, it was Broadcom, not important, but I think it was a Broadcom card with that 4x1 gigabit. Well, that price was always going up. We were selling more and more servers. Broadcom was happy because we are selling their network cards, but price was going up instead of price going down. And also 1 gigabit today, we see more and more customers going to 10 gigabit. And this is why HP said we're going to stop with onboard networks. Now we see 1, 10, 25, 40, even 100 gigabit is already there. Now we have more flexibility, and that's the whole idea behind it. Okay. Also here, I mentioned it in the beginning. There you go, Gen 10. By the way, Gen 10 is also changing today towards tech care, but with Gen 10 we had foundation and proactive care. Well, now you will see with Gen 10 Plus that is there with tech care support. But more information, hey, we had a presentation about that. When was it? I think 6 or 7 weeks ago. So the presentation of that webinar is available. So know that from now on in all those configurations, you will see tech care 24/7 next business day. It's still there, but now it's called tech care. So here you see as well, now we have SFF with 8, with 24. We have a model with 12 LFF drives, and also a model with 8 LFF drives available as well. And that's the start, CTO server. And then we're going to add CPUs and memory and backplanes, because CPU and memory and the network card is okay. But again, here you see that depending of what you need, you have those different backplanes available as well. And so you can install a primary, a secondary, or even a tertiary PCI card in there as well. Guys, this is all quick specs. It's in the presentation for your awareness. If you want more details, we can discuss this more in details afterwards when we're making that bill of material for you. Okay, the last model is that DL110. Not too much information about it because it's quite specific. One of the things that you see already, guys, this is the front of the server. Yes, we have power in the front of the server. Why is that? Because it's a server to put in telco racks. And telco has very often power in the front, right? And also networking in the front. So it's for that open RAN architecture. So it's an open network that is used now in the telco environments when deploying a 5G technology. And so this server is optimized to run those applications. So as you can see here, it's all go for telco. It's a ruggedized server, carrier grade functionality. And so this is what's happening. Instead of having a distributed network that we see now today with 2G and 3G and 4G, now with 5G, we see that with the edge, we're going to put intelligence closer to the antennas. Why is that? Yeah, because they need more power. They need more calculation power closer to those antennas to optimize the 5G traffic. Now, a DL360 is a quite big, it's a deep server, and this is why we have that DL110 now. You will see as well that also Edgeline is also a typical server that will be used to be installed closer to the edge. That's why it's called Edgeline, of course, right? So also there in Edgeline, you will see that also that third generation Intel CPU will keep on going in there. So there will be an Edgeline 920, for instance, with the MILAN CPUs that will be available as well for those specific workloads. I just put the quick specs again, the features in here. But of course, you prefer the pictures. So as you can see, front power, we have PCIe slots in here with the OCP slots and then the stand-up cards. This is a picture at the inside of the server. So it's a one physical socket Intel CPU that is in there. And what is quite remarkable, this is the back of the server. Cooling only. There's nothing else in the back. It's just fans. Okay, just to give you an idea of how it looks like. So this is the chipset for the techies amongst us. And then also about the DIMMs, since it's just one CPU, and also those telco applications, they don't need 6 terabyte of RAM. So there are only 8 DIMMs that are supported in there. And then finally, as well, since about storage, there's not that much possibilities about storage, right? So what will happen there is that they're going to put those M2 cards in there, SSDs in there. And then you need, of course, software RAID. Well, you will recognize from the past that SR100, which is software RAID. It's a SATA RAID controller in every ProLiant server, but then you need a driver and an operating system that supports this. Well, now know that there is a new thing from Intel. It's called Intel VROC. And at that moment, you will see that there is a dedicated management tool as well inside Windows. Also in Linux, it is supported. And then you can do software RAID as well. By the way, this is something that you will see everywhere in storage. Now, finally, before we dive into the storage, something quickly about memory, because you have seen that we have 16 DIMMs instead of 12 DIMMs. So we have 8 channels instead of 6 channels. And now you will see as well that we can go up to 3200 instead of 2900 in the previous models. What does this mean as well? Because we have that single rank and dual rank and quad rank, and also about the bits, you will see that those chips get more and more higher density. We're talking now about 16 gigabit chips that are being used in 8 rank, which means that we have now DIMMs up to 256 gig of RAM, which is insane, which is huge in one DIMM. Now you should know that, why do I put it in here with the population rules? We have UDIMMs, we have RDIMMs, but those higher end high capacity models are LRDIMMs. Yeah, and you should know that you cannot mix RDIMMs and LRDIMMs. Okay, because in the past, the 64 gig DIMMs were also LRDIMMs. So you should know that we don't have you cannot mix RDIMMs and LRDIMMs. This is not HPE. This is defined by AMD and Intel, right? Now, meanwhile, luckily, the 64 gig DIMMs are now RDIMMs as well. So you can mix them now with the lower capacity models as well. So therefore, I put more technical information in here for you or for your colleagues, the techies among us, so that you have an idea of how it looks like and what's coming. So it's called HPE Smart Memory. Here are plenty of part numbers, because also, yes, we have those different part numbers depending on where you're going to put those DIMMs in there. This is typical to HPE, but just to give you the idea about the models that are available. And so here are the differences. So you can see, hey, can I have that 256 gigabyte DIMM in Gen 10? No, that's not possible. So it's Gen 10 Plus. So it's the Ice Lake CPU that supports this one. Okay, so that's typically for those customers who wants 6 terabyte of RAM. Okay. Also here, note that we have that standard memory, it's cheap memory, the UDIMMs, smaller capacity as well. But most of the time we go for that smart memory because we have more guarantees, more support. ILO can see much more what's happening on those DIMMs. So I always suggest to go for that smart memory. Now about the population rules, it's a really easy one. Like I said, this is Intel information. You cannot mix LRDIMMs with RDIMMs. You should know that. Okay, so if you choose these DIMMs, watch out, because afterwards, if you want to expand, you have to add those same DIMMs. Of course, it's a matter of supporting this over time. It might change, but nevertheless, this is the information today. And as you can see in Gen 10, 12 sockets. Now Gen 10 Plus, we have 16 sockets. And yes, there is that population rule of where you can install those DIMMs. Just open up the server on the hood at the inside of the server. Yeah, there is that sticker always that tells you how to install those DIMMs. There's plenty of population rules that you need to follow. Like I said, I'm not going to read everything. I just put it in here for your reference. This is all from Intel. And this is how it looks like. This is the sticker at the inside of the shelf of the hood of the server. So you're going to populate it with 1, 3, 5, 7, and then 10, 12, 14, 16, and so on and so on. The typical population rules. The most important thing is you can go up to 16 today. And this is to give you an idea about the memory evolution. Okay. We have all those CPUs at the bottom here. We're coming from Nehalem, Westmere, Sandy Bridge, and so on, with Skylake, Cascade Lake, and now Ice Lake. Intel is at the 10 nanometer process technology with 8 channels. But as you can see, the CPUs are at a higher rate compared to Gen 10. This is why Gen 10 will remain existing. It's still DDR4. Probably Gen 11, I expect it will be done DDR5. But for that, we have to wait, of course, right? Good, finally. Still a lot of information about storage, because I told you there's a lot of changes in storage, and this is why I took specifically that third tech talk. So this is a specific tech talk just about storage. And if you cannot find, like I told you, it's techpro.hpe.com. If you cannot find it, send me an email, send me a WhatsApp, call me, and I will point you to that tech talk with more information specifically on storage. Here I took the most important slides for you. Okay, so what do we have? We have the traditional controller naming. For instance, we have an SR408, which is the most popular controller. SR, it's a smart array. Oh, smart array exists already, I think, since compact time. Yeah, it exists already that long. It's a really good controller. Now, know that smart array brand name is being discontinued. First of all, it's just a RAID controller. Okay, we don't call it smart array anymore, because SR, until now, we were using always the chip from Microchip. It's a company, Microchip, and we put that chip on our HPE RAID controllers, and we were using it a smart RAID RAID controller. Well, now we want to open up the market. We want to be, yeah, it's an open network. Everyone wants to choose. So this is why today we will open up the market as well. We're going to use as well now MR controllers. Now, MR controllers are mega RAID controllers. They are built by a Broadcom. And know that there's also an NS controller available, NVMe Shield NS, and this is from the company Marvell. Okay, so today with HPE, we have 3 options. We have SR controllers, they keep on existing, we just don't call them smart array anymore. We have MR controllers, and we have NS storage. Okay, then MR, SR, NS. Then that green first digit is still 1, 2, 4, and 900. In the past, we had 800, so now it's called a 900. That's the MR controller, for instance. And so the 100 series is still software RAID. We have an essential, we have an advanced, and we have a performance controller. The second and the third digit is the number of lanes. Okay, so we have 8 or 16 or 24 lanes. We'll see in the future what will arrive. But the second and the third digits just points to the number of lanes that you can connect. Then, is it an I? Is it internal ports? Is it an E? Is it an external port, for instance, to, I don't know, a tape drive or a JBOD, an external disk shelf, or IE, which is a card that has internal and external ports. And then at the end, behind the dash, we have some options, like for instance, the form factor. Is the PCIe card, so it's a stand-up card. Is it an A? Then it's an AROC modular form. So at that moment, it looks like it's like a mezzanine card in a blade server in parallel with the motherboard. We have a C, which is a compute modular form factor, which will be coming in the future as well with the OCP standards. And then the M is indeed for Synergy. It's a mezzanine card. Okay, so the naming convention is still there, always good to know. And so now you will see up to the performance. This is an overview today of the models. So we have the essential models. We have now also these are SR, yeah. So this is smart RAID. So now we also have mega RAID. That's the 216. You always see that they have 16 slots. The other ones, they have 8, which is lower ports for 1 drive cage with 2 drive cages. And now we have that 932. So we don't need that splitter anymore. That SAS expander, because now we can install up to 32 drives directly attached to that SR smart RAID controller 932. 32. And as you can see, we have some other MR cards as well. So, hey, guys, more choice. Yay, happy, right? More choice for you. And then we have also the NS models. So that's the Marvel solution with for local storage for specifically for boot devices. More details coming as well. And like I said, now we have that SR100R, 100i that exists already a long time. But now we also have Intel VROC, which is that second option for software rate. Now, why do we have that 932 now? Because it's that 932 that supports, for instance, that tri-mode functionality as well. Remember tri-mode, this is what we're gonna see here in the remaining slides. And so all of them, as you can see, all those models, they have specific features and workloads. So where do you gonna use which models? Okay. As you can see as well, we're always talking about 1 and 2 gig of RAM. Well, this one has 8 gig of write cache. Okay, this is really a beast. This is really the performance model. The 400 series, they have typically 4 gig of cache. Also, they have SAS connectivity, of course. So every controller specific features. Now about documentation, because you're going to say, hey, I need more information. No problem about the SR, about the MR, because they have specific, by the way, they have specific user tools. I have a screenshot of that in a few slides from now. So, but know that there are user guides available. There is CLI. You can find all the information in the quick specs as well. I found a comparison between the microchip smart rate, it's SR, and then that Intel solution, the VROC virtual rate on CPU. So VROC means virtual rate on CPU. Okay, if you want to do it on SATA, it's for free. If you want to use this functionality, software rate on the CPU by Intel, you want to do it on NVMe, well, at that moment, it's it has a certain price. Okay, nevertheless, put a rate controller in there. Yeah, so this is for the lower end, cheaper solutions. For instance, in the DL110, good option, of course, there. You got to take a look at the operating system support. SR, Smart Rate, the 100i, was supported only by Windows. Well, now know that VROC is supported by other applications, like, for instance, VMware and Linux as well. Specifications, I'm not going to dive too much into details. It is for your reference. We see the tools that you're going to use, the cache that they have, how you can connect to it, how many connections that you have. But the most important, as you can see here, that these next generation cards, they all have PCIe Gen 4. So they are ready for the future. Okay. Why? Take a look at the performance. Gen 8, Gen 9, Gen 10, and now Gen 10 Plus. We have much more bandwidth. Since we have much more bandwidth, we have much more IOs per second that can go through, right? And you see the difference as well about, yeah, the DDR4 that is used as a cache. That SR932 has, yeah, much more DDR4, more bandwidth. And this is why as well, you will see that the writes are much higher. Okay. This is a picture of the tools. So the left one, SSA, Smart Storage Administrator, you will recognize this one. This is the typical tool that you're going to use with the SR controllers. And we have a dedicated MR Storage Administrator that will be used for MR. Yes, I admit, two tools. I hope one day that HPE will put everything together, but today I have to tell you that we have two different management tools. Now, nevertheless, when you install that server with the SPP, the service pack for ProLiant, you will get the tool installed. Okay, and honestly, I think that one day, maybe, I assume that they can combine all this together. Okay, now why is that? Because everything is going towards Redfish. Redfish is an open standard that is used also by the other server vendors. And it's that open language that will be used by those management tools. And this is why also from Gen 10 Plus and further on, we're putting everything on that redfish compliancy. And this is why those older OEM SR controllers will discontinue in Gen 11 on the management, of course, because they don't support redfish. And so this is as well a good example of all those controllers supporting redfish. If you go into ILO 5 of your server, well, here you see an MR, an SR, another SR, even an NS, and a VROC in there. Well, they all support redfish, and this is why now with ILO you can see all those RAID suppliers with just one experience. And this is the idea where HPE says we want to go to that one uniform language. Also, at that moment when you want to update the firmware and so on, we don't have those specific tools anymore, because now it's just since they are using all one same redfish language. At that moment, yes, we can make also your life over there much easier through ILO. Okay, so there will be much more coming for sure. So why is that? As you can see with Gen 10, we had a lot of SAS and SCADA, just a little bit of NVMe possibilities. Well, now with that tri-mode RAID, with those controllers, well, now in Gen 10 Plus, we give you much more flexibility. And that's what you have seen on those previous pictures that I showed you with all those backplanes. You just get more flexibility. Okay, so I keep on repeating because this is the information that I got from the storage tech talk. All the details are in there. So why we have that new backplane? This is then again the naming framework from the backplane, not from the RAID controller, but from the backplane. So also those backplanes, they have a naming convention. The bay count, is it small form or large form factor? Then the max link rate, remember all those lanes, that link was the highest speed, 12, 16 or 24G today. Then what are you gonna connect to it? Is it SAS? Is it SATA? Is it NVMe on a by 1 lane or a by 4 lane? And then you see that backplane manager. We have that UBM 1, 2, 3, and 4. So we have a converged small form factor smart carrier. Smart carrier is Gen 10. BC, basic carrier 2 and 3 and 4 is a basic carrier that's Gen 10 plus. And now we have a segregated and we have a converged. Remember, UBM3 was the most popular one. Why? Because converged means we can put SAS, SATA, NVMe on there. Segregated means that we have a specific traffic, or SATA, or SAS, or NVMe. And with that one, you can choose again between SFF and LFF, that low profile standard carrier as well. Because at the end, you will see here, SC is a smart carrier, BC is the basic carrier, and LP is then that low profile. By the way, I have a picture of it in a minute. We're almost through, because I see we arrive at the end, but we are almost through the presentation. So I told you about that backplane transitioning. So we're talking today about that basic carrier. Okay, we have that segregated, we have that converged one. So we have UBM2 and 4, which is a segregated one for SAS or NVMe, or we have the converged where we have SAS and NVMe, which is then UBM3. Okay, with that by 1 and that by 4. And why we have that by 1 and that by 4? Well, remember this slide back again. It's all about the bandwidth. Okay, do you have point-to-point NVMe? Then you have more drive base, you need more bandwidth, or you're going to put it behind a RAID controller. Even then you get full performance, and you have, of course, RAID protection as well. So there you go. You have to choose between the capacity or the performance, but you can choose both of them. And this is then, of course, the same picture again, the comparison between a DL380 and a DL385 by populating all the slots with a by NVMe by 4, or by using that SR932i with insane amount of cache on there with a buy 1 NVMe, but at that moment we can have much more capacity, of course, because then we can go up to 38 NVMe drives in a DL380 and 36 drives in a DL385 with AMD. So finally, here are the drives. Yes, we still have those drives, 7.2K RPM, 10K, 15K RPM in LFF and SFF. They keep on going. It's just with that new basic carrier, you see the growth, you see the capacity that is going up. So it's not end of life, right? Those spinning media, it keeps on going. If we take a look on the 10K and 15K RPM drives, well, today, I don't see new development. Yeah, on that capacity, I don't see these numbers really going up. Where I see changes is on the 7.2K at the midline SAS drives. So there today, 16 terabyte, 1820, there's even more coming because they're using new technologies. This is outside HPE, of course, but you should know aware that Toshiba, Seagate, they're working on helium-filled drives and so on to optimize the cooling, to get higher capacities as well. Now about SSDs, today it's still there. We have, depending of the form factor, the endurance, important there. We had already the RI, read-intensive, mixed-use, write-intensive drives. Know that today we also have the very read-optimized drives. So the you have less writes there, but they have higher capacity SSD. You have the performance of SSD, but the low latency of SSD, but we're not going to write that many data to it. Also back again for archiving, for instance, database reads, you can put it on there. So we have those types of SSDs. I don't see much changing there. They all keep on existing, only also there the capacity is going up. Okay, so 16 terabyte is not, it's a default model today available. So it will go keep on doubling as well about those SSDs. So here's a nice picture as well to show you the difference between where we are coming from. And so now we have, of course, NVMe. Latest information about, first of all, the interfaces again, because of course SSDs are also using the speed of PCIe generation 4. This is where we are today with Intel and AMD. Well, know that of course there will be one day PCIe Gen 5 as well. It's all about that bandwidth that will be used. And so I promised you this is the picture of that of the drives. Yeah, so we have now, we call it an LPC, a low profile carrier. It's the new LFF drive. It looks small, but it's 3.5 inch, right? And then we have the basic carrier, which is now our small form factor drive. Yes, there are 2 LEDs on there. To give you an idea, why are we doing this? Well, in the past, there were drives of Intel, from Samsung, from some other companies as well. And then we had all those different SKUs to go to your customer. Well, now today, all those raw drives, it's just one SKU anymore. They have that unbranded spec tied to those multiple raw drives. And then one drive is unavailable, then HPE can switch to another drive really easily since we're all using the same basic carrier as well. And so talking about those carriers, by the way, this is the end. Why this is important and not important, it's just to give you an idea. There are so many carriers and everyone is picking their own standard. Yeah, and just to give you an idea, so the typical server vendors like HPE and Dell, EMC, and so on, we are focusing on this standard. Okay, it's called the E3S 1T and 2T standard. You will never see this. This is open platform discussions. But as you can see, there are other markets like Intel, like the public cloud guys, the Facebook companies. They have their own servers. Well, they are using another standard for there. These are some kind of an M2, M3 cards that you are using. But so the traditional server and storage vendors have chosen to go to this basic carrier. Okay, and this is what we are seeing now. So from Gen 10 Plus on, we are following now the open standards that are being used by other vendors as well. We don't want to push out anything from those companies. It's just a choice that they make. Okay, good. I keep on repeating because this is my last slide. I told you Gen 10 is not end of life. Okay, Gen 10 will stay there. Gen 10 Plus is targeted at the customers needing the highest performance. So don't expect now at Tech Data that our stock, that all the DL380 Gen 10s will be out of stock and we only gonna get Gen 10 Plus. No, this will not happen. Why not either? Because there are so much possibilities with those backplanes that we are taking a look now. What needs the market? Do they need that converged backplane? Do they want NVMe only? Do they need SAS or SATA only? So initially it will be CTO, and then when we see that there's a need for this and that, okay, you will see things coming available on stock as well. Of course, it needs to be available as well by HPE and Intel, because also Intel is holding the releases of the availability of all those CPUs. It is available, but we have to take a look indeed at the production times and availability. So most important thing is Gen 10 Plus is not a replacement, it's an extension of the Gen 10 server. And so it's all about when to pick AMD or Intel. All of them, they have their specific unique features. Okay, there you go. This is the end of my presentation. I'm sorry for those 7 minutes that I'm out of time. I hope that it was interesting. If you have more information that you need to choose which model, availability, pricing, yes, it's in OCA. All the models are available in OCA. Go take a look there. Otherwise, here's the email address of the HPE team at Tech Data. Here's the phone number as well. Probably you know all these faces, Christophe, Wim, Steven, they are experts in all this. You know where to find me as well. So thank you very much for your time. I will stay here, by the way, for the Q&A. So if there are questions, please let me know. Otherwise, there is still next week a SimpliVity update. There's a networking update. There's an HP Discover recap later on this month as well. So if you're not registered yet, feel free to register.